Welcome to my class. In our last class, we have already solved 4 problem sums based on addition and subtraction of algebraic expressions. In today's class also, we will be solving these 4 problem sums which are again based on addition and subtraction of algebraic expressions. So let's get started. The first problem sum says that we have to subtract the sum of these two algebraic expressions from the sum of these two algebraic expressions, third and fourth. So next what we will do is we will perform these two additions separately, and then from the first result of addition we will subtract the second result of addition. This is one way. The second way is we will identify all those variables where here we have L, M and N square, these three variables. So in the next line itself, what we can do is we can group all these terms based on their variables. So here we have in total 4 algebraic expressions, and in every expression we have 3 terms. So according to their variable, which are L, M and N square, here we can group or combine all those terms in the next line itself. So we don't have to perform the addition separately and then subtraction. But I will go by the first method that I told you, and if we go by that method, there will be less chance of doing mistakes. So first we will perform the addition separately and then subtraction. Now what we will get next is 9L minus 3L, it will be 6L plus 2M plus M, it will be 3M. Then 4n square minus 3n square, so it will be only n square. So this is the first result of addition. From here we will be subtracting the second result of addition, which is 3L plus 2L, so it will be 5L. Then minus 4m plus 3m, so it will be minus m. And then minus 7n square minus 4n square, so it will be minus 11n square. Now again we will group as per their variables. So here it is 6L, then minus 5L. Then after that we will be combining the m. So here it is 3m minus, and here again we have another minus, so it will be plus. So plus m minus 1 minus m, it will be plus m only. Then here again we have n square, and again minus 1 and minus 11, so it will be plus 11 only. So plus 11 n square. Then after further simplification we will be getting, it will be L, then we will be having 4m, and then 11 plus 1, it will be 12n square. So this is our simplified or final answer. Next we will subtract the result of addition of these two algebraic expressions from 5. Since we have already simplified many problem sums based on addition and subtraction of algebraic expressions, so this one looks simple to us. 5, then from that we will be subtracting this result of addition. So here we have one x term, then x square, and we have constant. Accordingly we will combine them. So here minus x square, then in the second expression we have plus 7x square, we will combine them together. And then in the first expression we have 2x, here we have minus 4x. As we are adding, so the sign of the term will be the final sign that we will be considering. Now here we have 5 and then minus 3. So after simplification we will be getting, so it will be 7 minus 1, 6x square, and then 2x minus 4x, so it will be 2x, and then 5 minus 3, so it will be 2 only. Next we will be writing this way: 5 minus 6x square, then minus minus plus 2x, then minus plus minus 2. So finally it will be minus 6x square plus 2x, then 5 minus 2, it will be plus 3. And this is the simplified answer of this algebraic simplification. Now we can arrange this way also: 3 plus 2x minus 6x square. If the first term, if it is negative and that doesn't look good to us, we can arrange this way also. Next we have to simplify this algebraic expression where we have 3 separate algebraic expressions, and we have addition and subtraction of the terms in mixed form. So what we will do is we will combine the terms as per their variables. So here what we can see is we have y square, one variable, then we have y here, and then we have constant term, that means y to the power 0. In the second expression also we have y square y and constant term, and in the third expression also we have y square y and constant term. So in these three algebraic equations we have in total these three terms of variables, or we have the variable y and we have different powers 0, 1 and 2. So as per their power we will combine them. So here from the first expression we have taken 1/3 y square, then in the second expression we have plus 2y square, but we are subtracting, so minus 2y square we have written here. Then we have in the third expression minus 2/3 y square, but we are again subtracting this whole third algebraic expression, so the term will be taken as positive, minus minus plus 2/3 y square. Then in the second bracket or in the second combination we have taken minus 4/7y. Then from the second expression we have 1/7y, and we have negative sign also here, we are subtracting, so minus 1/7y. Then in the third expression we have plus 2/7y, and then since we are subtracting, so again it will be negative, minus 2/7y. Then for the constant terms it will be 11, then here it will be minus minus plus 3, and here plus minus minus 2, and then we will simplify these coefficients of the terms of y to the power 0 and y square. So it will look like this. Now if we take the LCM, so LCM will be 3 of the denominator, so it will be 1, then it will be minus 6, then plus 2, and then multiplied by y square. Then for the second expression the LCM will be 7 only, then minus 4, minus 1, minus 2, and then the term variable is y, and then 11 plus 3, 14, minus 2, it will be 12 only. It's simple. Then if we further simplify, then it will be 2 plus 1, 3, minus 6, so minus 3. Minus 3 divided by 3, it will be minus 1, that means minus y square. Then we have minus 4, minus 1, minus 5, minus 2, minus 7. Minus 7 divided by 7, it will be minus 1 only, so minus y, and then we have plus 12. So this is our final or simplified answer. We can rearrange the terms this way also, 12 minus y square. Then the next problem sum also, we have to simplify addition and subtraction of algebraic expressions. We have in total 1, 2, 3, 4, 5, 6, 7 terms. So first we have to identify that what are the different terms are there, different variables. So here a square b square c is one term, and we have a square b square c, and then we have another a square b square c here. Then we have ab square, so ab square c is another term that we can see here, and ab square c, we have another term here, ab square c. Then we have abc square, so abc square, we have another term, abc square, we have another format, so abc square, let's find, and if there is any other, we have another abc square here. And then the final term is, the last term is a square bc. So this is the fourth format of the terms that we have in this expression, so it is a square bc. So in total we have 4, and accordingly we will combine their coefficients. So after combining, it will look like this. Next we will simplify the coefficients. So here if we take the LCM of the denominator, it will be 10. Now 10 divided by 2, so quotient will be 5, so it will be minus 5. Then 10 divided by 5, quotient is 2, so it will be minus 2. Now it is a square b square c. For the second factor, if we take the LCM of the denominator, it will be 6. 6 divided by 3, quotient is 2, so it will be 2 plus 1, so it will be a b square c. Then for this term, the LCM will be 4 7s are 28. 28 divided by 4, the quotient will be 7, so it will be minus 7, and 28 divided by 7 is 4, so it will be minus 4, and it is abc square, and then the last term is 1/8 a square bc. Now if we simplify further, it will be minus 7 by 10 a square b square c. Then it will be 3 by 6, that means 1 by 2, so plus 1 by 2 a b square c. Then we have minus 11 divided by 28, so minus 11 divided by 28 a b c square plus 1 by 8 a square b c. So this is the simplified or final answer of this algebraic expression. In the next class, we will be solving a few problem sums based on multiplication of algebraic expressions. With this, I end today's class. Thank you.